Hi folks, this is Checkpoint Quiz 10.1. Number 1, we're asked to convert an angle whose measure is given in the degree, minute, second system to decimal degrees. We're asked to round our answer to 3 decimal places. So the key to this problem is 1 degree is 60 minutes and 1 minute is 60 seconds. So if I want to convert this to decimal degrees, I know that the 3 minutes is going to be 3 minutes. To convert that to degrees, I know that for every 60 minutes I have 1 degree. And so 3 minutes is 3/60ths of a degree, or 1/20th of a degree. And 11 seconds, well, 11 seconds, I would multiply that by, for every 1 degree, there's 3,600 seconds. And so this is 11 over 3,600 degrees. So, you put this together, 42 degrees, 3 minutes, 11 seconds is equal to 42 degrees plus 1/20th degree plus 11 over 3,600 degree. And if you run that through your calculator, you would get approximately 42.053 degrees. And so that'll do it for number 1. Okay, number 2, we're asked to do the opposite. We're given the measure of an angle in decimal degrees, and we have to convert back to degrees, minutes, seconds. So we're just going to ignore the negative for now. We'll put the negative in at the end. Let's look at 13.621 degrees. So how many whole degrees do we have? Is 13 degrees. And then we have this many degrees left over. These are partial degrees, and so the first thing we'll do is see how many minutes this is. So we'll convert this to minutes. For every 1 degree, there is 60 minutes. And so the degrees cancel out, and I get 0.621 times 60, and this will be minutes. And if you go through the calculator, you will find that this is approximately 37.260. All right, minutes. So this gives us 37 whole minutes, and then this many parts of a minute. So I'm going to take that now, the fraction of a minute, and I'm going to convert that to seconds. For every 1 minute, there's 60 seconds. And so I get 0.260 times 60 seconds. And if I go through the computation there, I get 15.6 seconds. We're asked to round the answer to the nearest second, so if I round that, that's going to be 16 seconds. So I put this all together. 13.621 degrees is 13 degrees. So 13 degrees, 37 minutes, and approximately 16 seconds. So for my final answer, negative 13.621 degrees is approximately negative 13 degrees, 37 minutes, 16 seconds. That'll do it for number 2. All right, number 3, we're asked to graph each of these oriented angles, classify the angle according to where its terminal side lies, and give 2 coterminal angles, one positive, one negative. So in part A, we're asked to graph theta equals negative 240 degrees. So we start off with the XY axes. We're plotting this in standard position. That means that the vertex of the angle is at the origin, and the initial side lies along the positive x-axis. All right, we're given degree measure, and we know in degree measure, 1 revolution accounts for 360 degrees. Since we're graphing a negative angle, we're going to be rotating clockwise. Okay, so I have to imagine where 240 degrees is going to lie. I start out, one revolution is 360 degrees. That means a quarter revolution is going to be 90 degrees. So I start here, I rotate to there is 90 degrees. That would be 180 degrees. That would be 270 degrees. And so this is going to be 30 degrees shy of that. So I'm going to rotate around 90, 180, and then an additional 60 degrees. And that's going to give me theta is negative 240 degrees. Since the terminal side of theta lies in quadrant 2, we would classify theta as a quadrant 2 angle. Now we need to find two coterminal angles. And remember, coterminal angles mean they have the same terminal side. And we know that any coterminal angles then have to be off by a revolution, or some multiple of a revolution. Since we're using degrees, we know that the revolutions account for 360 degrees. So one way to get a coterminal angle is take our angle theta and add 360 degrees to it. So if I do that, I get 120 degrees. And even though we're not asked to do so, it's instructive to actually plot alpha. If we plot alpha in standard position, we're going to start here and rotate counterclockwise 120 degrees. So that's where alpha is. We can think of alpha this way. If we think of it as the sum of these two angles, I can think of starting here, going negative 240 degrees clockwise, and then adding 360 means I'm going to be going 360 degrees, one revolution counterclockwise. So I go clockwise 240 degrees, 360 degrees counterclockwise will land me right there. To get another coterminal angle, I'll call that beta. I can take theta minus 360 degrees. So negative 240 degrees minus 360 degrees. It gives me negative 500, negative 600 degrees. If we wanted to plot beta in standard position, I would start here, like so. And the negative, once again, means I'm rotating clockwise. Since that's more than 360 degrees, beta goes around one complete revolution to account for the negative 360 degrees, and then another 240 degrees clockwise to get me there. So that's beta is negative 600 degrees. All right, so that's how they all fit together, and that'll do it for part A.